Welcome everyone to this new edition of our holographic podcast or HoloChat. And today I have a very special guest with us, Dr. Antuñano Melchor. Welcome to our show.
Thank you, Fernando. It's a pleasure to be here, and thank you for the invitation.
Melchor, my first question is related with space medicine. How does space travel expose individuals to a more hazardous operations environment compared to commercial airline transport?
So yes, definitely there is a big difference between passengers flying in commercial aviation flights versus going to space. Now it makes a difference if you're in a suborbital flight versus an orbital flight. The difference there is that suborbital flight will be a very short time of exposure to microgravity, 3.5 to 4 minutes. But once you are in orbital flight, you can spend there hours, days, weeks, or months at a time, or even longer than that. So the effects on your body of being exposed to microgravity are effects that you will not experience being a commercial passenger in an aviation environment. Then also the acceleration profile. To get to space, of course, there will be higher acceleration loads compared to flying in a commercial aircraft. Then also thinking about potential radiation exposure. Yes, you are more likely to have exposure to radiation if you are in a space flight as opposed to a commercial aviation flight. And of course, there is another difference depending upon how much space you have available on board the vehicle or the space station, if you go to an international space station. Well, what will be the effect of confinement, that you may not have as much space, plus you are going to be there a longer time if it is an orbital flight for a long period of time. So that may have some psychological implications for you that in the worst case in commercial aviation, we're talking about a 20 to 22-hour flight, and that's it. Compared to space in orbital, not suborbital, but orbital, that can be, as I mentioned before, hours, days, weeks, or months.
Wow. About that, what psychological, physiological, environmental, and operational stress factors affect humans during space flights?
Well, along those lines, once again, if we think about microgravity exposure is going to affect not only the way that you are going to position yourself, but how you translate from one location to another one in microgravity, not being under 1G conditions like we are even in a commercial aircraft. Well, the issue is that you have to learn how to push yourself from one location to another location, but then how to keep in mind that also the relationship between what's up, what's down, is completely different in microgravity because there is no gravity, so your body doesn't feel what's the equivalent of up and what's equivalent of down. So you could be with your head down, and that to you in microgravity doesn't make any difference. Other implications there is, of course, the longer you are exposed to a space flight, you will start losing more muscle mass, you will lose bone mass. Why? Because you don't need those in microgravity, even though part of the countermeasures are to exercise a number of hours so that you can try to maintain the muscle mass and the bone, but you still lose some of that. There are other changes that have to do with your physiology. As soon as you get into microgravity, suddenly you have what is called the fluid shift. Normally we have most of the blood volume from our belly down in 1G condition. But once you are in microgravity, of course, suddenly you have all of that fluid shift that goes to the top of your body, and that explains, for example, why you see moon phases on astronauts that, well, it was suddenly a lot of fluid going to the head, so your face gets swollen. Eventually that goes down because then you will end up peeing more and get rid of some of that extra fluid. But obviously those are acute changes. You may have some space adaptation syndrome that may include, for example, the equivalent of motion sickness, but in space is called space sickness. That yes, you may feel disoriented, and eventually you will feel better, but depending from individual to individual how long it takes to do that. There are changes in your immune response that we don't know exactly why right now, but in general, most infections are more serious. The effectiveness, for example, of antibiotics decreases, our immune responses go down. So there is a lot that we need to learn that we still don't know exactly.
Wow. Now, talking about electronic devices, How have digital electronic devices impacted scientific breakthroughs in advanced medical technologies?
Well, there is obviously an exponential development today of medical technologies in all areas. And you're talking about not only biomedical sensors, many of those are the wearables, like your traditional, the ones that you use on your wrist, or even your cell phone that is giving you now information about you. But now the question is, can we use some of those devices not only to monitor what happens to people, physiological responses in space, but also what is the usefulness of those devices? We know from some recent commercial space flights that they have taken cell phones, they have taken some portable ultrasound devices to do some measurements in space. But what else can be done with newer technologies? Of course, they have to be tested. And also keeping in mind that many biomedical devices were designed not to be used in flight. They were designed for people on the ground. So we have many of those technologies that may be impacted by the microgravity in space, and maybe also be impacted by the increased acceleration during the flight going up. But once again, because they were not designed for the purpose to be used in space. We will learn. The more we fly, the more we test, we'll determine what will be their usefulness later on, particularly to monitor, let's say, people now from the general public that will be space flight participants, so the ones that are going in space right now, that they may not be the healthy astronauts that we're used to or career astronauts, but that they have medical conditions. And for some of those, yes, we may want to be doing some biomedical monitoring in space to see how they are responding because they have certain medical conditions.
Can you provide us with some examples of recent breakthroughs resulting from exponential technology innovation in medicine?
Oh, yes, there are many of those. For example, in the genomics area, you have more and more genetic studies that are identifying, for example, biomarkers for some medical problems, so that you identify also if you have predisposition to develop certain medical conditions, but also the severity of some illnesses, like, for example, for cancers. Now you can do some genomics testing to identify, the type of cancer cells and the aggressiveness of the cells, but then also identifying for example, your predisposition to certain stress factors. We know, just to give you an example, that exposure to radiation. We know that people who were unfortunately impacted by the nuclear explosions in Japan, in Nagasaki and Hiroshima, that many people died there, but there were people who survived. And the question is, how come they survived when almost everybody else died? And some of these people survived, and they survived until above 100 years old. So the question becomes, do they genetically have something different that were not as negatively impacted by radiation exposure as most other people? And probably the answer is yes. Is it possible that we have genetic differences that we have better tolerance than other people to acceleration, to microgravity, other stress factors that happen in flight? That's possible, but we need to do more research in connection with that. Other breakthroughs also with the microbiome, the human microbiome. In fact, if you remember a couple of years ago, for the twin astronaut study, that one of the twins was on board the International Space Station, the other one was on the ground, and they were doing some microbiomic studies to determine what was the difference of the space environment compared to the Earth environment. And yep, it's a very interesting result. So there are additional studies going on in that particular area. But then you have also the issue of stem cells. Can you use mother cells to do regenerative organs, tissues? Is that something that could be done, for example, that you have your own mother cells in long space flight? Could you actually modify some of those stem cells that if you need some replacement of tissues or organs or whatever, eventually, well, you use your own so you will not reject them. There are issues related to medical robotics. There are issues related to even neurotechnologies that have to do with the functioning of your brain. A lot of developments having to do also with neural technologies, for example, brain-computer interfaces that are currently being investigated for using your brain to directly control devices, Some of those developments are happening already to control through brain-computer interfaces, wheelchairs, prosthetic arms, prosthetic legs. Well, what else can we do that we can control that way through a brain-computer interface? We have developments in nanotechnology, specifically in the area of nanomedicine. In nanomedicine that, well, there are already a couple of chemotherapy agents that for people who have cancer, that you can actually deliver the chemotherapy agents using nanoparticles that then you introduce into the body. Then you make sure that they are released where you have the cancer area instead of essentially affecting or impacting the entire body. So many of these developments, also with the analysis of data, a lot of data that is being generated now with medical technologies. Well, how can you identify, for example, predisposition to certain conditions, or how you are likely to react to exposure to certain environmental stress factors? So yes, definitely medical technology is having a huge impact, and it will continue to have more. Wearable devices, there are a lot of developments there. Equipment for physicians to be used, for example, in conjunction with cell phones. Well, that makes it easier. If you carry a cell phone in space, well, can you carry another medical device you attach to the cell phone, and now you can use for monitoring or for even for diagnosis? So an explosion of medical technology that is potentially having an impact.
Wow. About medical technologies for space, could you discuss the technological developments in genomics, gene therapy, microbiomics, as you discussed, stem cells, regenerative medicine? You mentioned artificial replacement of tissues, organs, body networks, medical robotics. Can you just discuss a little bit about that one?
Well, I discussed a couple of the other ones already. Let me mention now a little bit more about medical robotics, but also exoskeletons. So there's a lot of development, not only to, let's say, have a person recover from a particular problem. Let's say that you had a problem with a leg, and it's taking you some time to recover, or it may be a neurological problem that is affecting already your motion, your locomotion. Well, could you use some robotic support to restore normal function, or an exoskeleton, a leg, an artificial leg added to your own leg? And I'm talking about the exoskeleton that could actually replace your normal function, or go in the direction of even augmenting human performance. So there are developments right now in robotics and exoskeleton technology that, why do you stop at normal function, for example, to carry weights, to do certain activities, when you could probably enhance the capability of a human through some of those new technologies? There are some developments, for example, right now in several laboratories with the next generation of smart contact lenses that, well, initially restore visual acuity, but could you end up using some of those to allow people to see in infrared, to see in ultraviolet, to create now a way of creating information through the contact lens instead of having an external display? Now the contact lens is essentially your display to provide information. What about other smart devices, such as smart shirts? And there are many of those examples. In fact, I have one of those, where you can actually be monitoring cardiac function, you can be monitoring pulmonary function, temperature, all kinds of different things, because now you have sensors that could be added to smart fabric materials, and that gives you flexibility that we haven't had until now. So once again, there are many other applications that we can not only relate to the medical aspect, but also to the performance aspect of a person, augment capabilities, and expand human functions.
Wow. How might these technologies be practically applied to improve medical selection or health maintenance and performance assessment for space crews and passengers?
Well, there I would use the example, not there yet, but for example, with the genomic analysis. Can we identify once again people who have higher tolerance to microgravity exposure, higher tolerance to acceleration, higher tolerance to radiation exposure? So eventually it makes sense that if you identify those people who have those natural increased tolerance to those, they may make better people to go in deep space exploration, going to Mars. Why? Because they are less likely to have the impacts of radiation exposure or some of the other stress factors. So certainly that could happen. We need more research to go in that direction. The same thing is identifying other technologies that could replace or could actually, let me put it this way. There is right now a program, it's called the Para-Astronaut Program with the European Space Agency. Can we allow people with certain kinds of disabilities to become astronauts? And the answer is, yep, we can. But through the use of technology, through the use of human factors to modify maybe the design of certain vehicles, the design of personal protective equipment, all of that stuff. But as far as integrating the human needs through technology, we could accommodate people that today are not allowed to fly in space to actually let them do it.
Wow. Given the relative lack of knowledge and experience, what challenges and negative consequences of using advanced medical devices? Let me rephrase that. Given the relative lack of knowledge and experience, what challenges exist in approving the use of advanced medical technologies among space crews and passengers?
Well, obviously, the first step, and not only United States, but any country around the world, we have to have the certification of medical devices. And in the case of the United States, it's the Food and Drug Administration. So any medical piece of medical equipment, device, or even now, we're talking about even the knowledge, not necessarily a device itself, but information that we use for diagnosis, that we use for treatment, that we use for rehabilitation. Well, there is a certification process for all of that. So that's the first step right there. But that, at this point in time, is based on the needs of people on the ground. So now if we talk about, well, now the application to another environment like the space environment, then that corresponds to other entities like space agencies for them to determine whether or not there is a compatibility of that equipment with the safety of the flight that is not going to interfere with the operation of the vehicle or vice versa, but then at the same time may not represent a hazard to an occupant. And what would be the usefulness of such a device in a completely different environment compared to Earth's environment, with, once again, with microgravity, with issues about now, another factor that I didn't mention, but in addition to a confinement, you have that recirculation of air, you have the reprocessing of water, because you have limited supplies of all of those things. So what kinds of technologies can be used also to augment that capability to have consumables that not necessarily you have to rely on everything fresh that comes from Earth, so that you can recycle, you can reprocess, and then you can continue using it. Well, it's not just water, it's food. What about medications? What about the production of medications in space? Can we use some of the new technologies with 3D printing that you can actually develop some medications if you have the way of actually generating the actual chemicals that you need, and then take the right ones so that you could have different types of medications that you could produce up there when you actually need them. Not essentially, it comes kind of just in time production for the time when you actually need them, so that you don't need to waste space storing things that you may or may not use until you actually need them.
What additional scientific studies are necessary to understand the positive and negative consequences of using advanced medical devices during spaceflight?
Well, I would say not necessarily just with spaceflight, but starting here on Earth. When you are developing medical technologies, there is the positive use. There can be abuses. Let me give you an example. We have new generations of implanted medical devices, insulin pumps, pacemakers, defibrillators, and other devices that you essentially can reprogram wirelessly. So if you reprogram wirelessly, well, that gives you flexibility for the doctor who wants to make sure that something needs to be adjusted and is adjusted the right way. However, that also creates the concern that what about if accidentally it gets reprogrammed the wrong way, or on purpose, certain devices are reprogrammed the wrong way, and now the outcome could be a bad outcome just because of not doing it for the right reasons, or just because it became an accidental reprogramming of something that you didn't intend to do. So yes, we have to worry about that in connection with genomics. Well, yes, we're thinking about the positive use. Is there a potential for negative use? Just like almost every area of technology that you can think about, if somebody wants to use it for bad, well, there are ways. Some may be more severe implications than others, but we need to pay attention to all of those different issues. So it's not just the certification from the medical usefulness point of view, but what about the possibility of having hacking of medical devices? That should we have a standard, anti-hacking standard for medical equipment, so that nobody on purpose will change something unless there is a need to actually change it, the programming.
Wow. Talking about forensic implications, how can forensic medicine methods and tools address post-mortem implications related to these technologies?
Yes, and that's a very interesting question, because so far, for example, some of these technologies, in certain areas, when you do a post-mortem analysis, you want to find out the cause of death. But in some other cases, you want to know contributing factors that may have resulted, for example, in incapacitation. In aviation flight, in space flight, what led to that? So in that regard, with all of these technologies that are emerging, for example, stem cells, nanomedicine, having not only genomics is the analysis, what about gene therapies? That's another area. So how do we know that many of those new technologies may have had an impact on something that happened to a person who was using them that could have resulted in incapacitation or could have resulted in death? Well, that's an emerging field that we need to pay more attention to that. Yes, for example, there is a discipline that is called genotoxicology. There is another field that is called nanotoxicology related to materials, but just specifically related to aviation and space environment. Well, is it possible that if you introduce like a nanoparticle into the human body through a bloodstream to deliver something else, that could trigger some problems as a result of changing pressure that could lead, for example, to triggering decompression sickness, because now you have a physical object. Yes, it's a nano object, but could that trigger the formation of a bubble as a result of change in pressure, like it happens on scuba divers, but also happens to pilots exposed to a decompression in flight? But could you trigger that, or could you actually increase the susceptibility by using some of these things? We don't know. What about some of the long-term side effects of some of these these new developments, like the gene therapies, the stem cells, the once again, nanomedicine, nanoparticles? We still don't know. So we'll have to learn a lot about those things because we don't have all of the answers.
How can space medicine providers stay informed about advanced medical technologies already in use by space crews and also by passengers?
That's an interesting question, because you have noticed that more and more people, including yourself and myself, we carry smart devices, including a cell phone that now you can do some biomedical measurements right there. But you have the wearables on your wrist, you have all kinds of different types of wearables that are collecting biomedical data. So that could be useful depending upon the accuracy of the data that you are collecting. But then at the same time, could you, for example, extract some of that data from some of those sensors when something happens so that it helps you identify something that went wrong? And we have a new technology, for example, the continuous glucose monitoring sensors, that you don't no longer have to every day or every time that you are going to have a meal or after a meal, pinch your finger, get some blood to get your blood glucose. Now with the continuous glucose monitoring patches, you can keep them there for a couple of weeks. Now, in fact, some of the new generations, maybe for up to a month. And now you have a better control of what's going on with a diabetic pilot or a diabetic astronaut or a diabetic passenger, where you can be monitoring at a more frequent, let's say with more frequency, what is happening with the blood glucose. So that leads to a positive outcome, because now you have better control of what's happening with both the use of medications, but also the control of your blood glucose level so that you prevent some of the consequences or some of the complications of not having a good control of your blood glucose real time. So yes, some of those technologies obviously very useful, but we need to learn about how to use them correctly in different environments. So are those or some of those devices equally effective, for example, in microgravity or in an environment that you may have exposure to other stress factors related to the operation? Could be the acceleration, could be the radiation exposure, not necessarily ionizing, but could be charged particles like protons that are very common in space as well. So those are things that we're going to learn.
Wow. Talking about data, how do you manage the exponential growth of patient data in healthcare settings?
That's a very interesting challenge because, yes, we have been generating so much more data now in the medical environment that the challenge becomes not only long-term analysis of the data, but even real time, like when you have imaging studies going on right now. Could be ultrasound, could be CAT scans, all of those that connect a lot of information. Well, now for several years, artificial intelligence is being used to essentially do the initial screening of those tests, not to diagnose what's going on with the images that may indicate some pathology, but which are the ones that probably should be sent to the imaging specialist so that that person or that specialist can spend more time identifying what the problem is. Because right now, with that much information, is overwhelming for the existing number of imaging specialists, for example, in the United States. So with those new technologies using artificial intelligence, that's making a difference because that's doing the triage. And then now we can say, now the specialist takes the time on those that require more careful analysis and at the same time to make a decision about what the problem is all about. So yes, we're going to see more and more applications of artificial intelligence in medicine that will help. They will not replace the doctor, but they will provide additional information that will help not only analyze the data that has already been collected, but maybe even real time do analysis of the data being generated. So that will be a huge plus right there.
What human factors are critical for the operational performance of space crews, and how do they impact crew selection and training?
Well, human factors by definition is the relationship between the human, the machine, and the environment. So depending upon where you are is what factors will have an impact on you as a human performing in that environment. So for example, in space, well, you have to consider microgravity. That is not the same as operating in a 1G condition like here on Earth. You have to consider, once again, all of the other stress factors in flight that from a human-machine interface, we need to protect the humans. We need to have life support systems. We need to have, for example, systems to protect right now against radiation exposure in space flight. Well, that's another human factors consideration, but also the design of the interfaces, the design of the control systems, the design of everything that has to do with a human operating machinery. And how do we make sure that that relationship between the machine in that environment, which now makes it more challenging, let's say in the microgravity environment, will be compatible with human capabilities? So we need to make sure that that relationship between the machine and the environment, it is a synergistic relationship where through technology and through knowledge, we make sure that humans will be able to continue operating in these unusual environments by paying attention to that relationship between those three factors. And that's essentially not only in space, but that applies to everything else that we do when we develop aircraft, when we develop cars. Always the human factors are important.
Wow. Now, talking about accident investigations. How do medical and human factors play a role in aerospace accident investigations?
Well, we have been doing that since the beginning of aviation, but also since the beginning of space activities. Yes, if there is a bad outcome, particularly for the crew members, we want to know What happened? Not necessarily just if there was a malfunction of the vehicle, but what were, for example, injury patterns? What were the other factors that may have resulted in initially not only the injuries, but could be also the performance impairments, and then ended up in the fatality. So every time that there is a fatal accident, we learn a lot. And that information that we collect is useful so that if there is something that we can modify an operation, we can modify the design of equipment, we can modify that human factors interface, well, then we can prevent future accidents from happening if we apply lessons learned in the past. For example, as you may remember that at some point, well, we have one of the Apollo mishaps where they were testing the system on the ground, and at that point in time, it was a 100% oxygen environment. Unfortunately, there was a problem with an electrical system that ignited the 100% oxygen, and unfortunately, the three astronauts that were inside that Apollo capsule, well, they passed away. Well, as a result of doing the investigation, not only of what happened with the malfunction, but also what happened with the humans, well, the decision was made that instead of using 100% oxygen, it was going to go to a gas mixture to decrease the risk of fire in an oxygen-rich environment. So that's one example right there. But there have been other lessons learned from mishaps, space mishaps, having to do, for example, with the need to have full pressure suits. There was also a Soyuz accident where a faulty valve in the Soyuz capsule upon return to the atmosphere actually depressurized the Soyuz capsule, and at that point in time, the cosmonauts were not wearing full pressure suits, so there was no backup to that one. Unfortunately, they passed away because of depressurization. From that point forward, it became a requirement to have a full pressure suit that would be the backup in case that the pressurization of the vehicle failed. So every time that we have a mishap, and it not necessarily has to be an accident with fatalities, could be incidents, but are significant incidents, we learn a lot from those lessons, and then we can apply those lessons to make the operation safer in the future.
Wow. Are there any specific protocols for examining space crew fatalities related to evidence of new advanced medical technologies?
That's part of the challenge that I mentioned before. I have asked some of our people who are involved with forensic analysis of remains, and I have asked the question, well, do we have the technology right now to look for evidence of, for example, nanoparticles in the remains? And right now, we don't have them. Do we have evidence or methodologies to help us find, for example, evidence of stem cell treatments, of gene therapy treatments that are happening in some countries around the world, but how do we look for evidence in remains? So that's another challenge right there. Now, where we are getting information is obviously in the biomaterial toxicology, because as I mentioned before, there are emerging fields, toxicology, but for biomaterial toxicology that has existed for years. But some of the new materials that are being used, well, are different than what we have been using for years. So definitely that's another area that requires more research. It requires more development of methodologies. But you have to also keep in mind that the number of people that may be in that situation is very limited. So what's truly right now the market to invest a lot to develop new procedures when you don't have to use them? When most of that analysis has to do with not space flight, and not even with aviation flight in general. So can you justify going into new areas just because of a different environment? That's a very interesting question, but it's also a very interesting challenge.
Wow. Melchor, this is one of the first holographic interviews. People may be watching this not only today, 10, 20, 30 years from now as a historical document. Is there a message or something you want to say to future generations watching this in 20 or 30 years from now?
Oh, definitely. And I would say I started my main message with, we have to welcome change constantly. And part of that change is technology, but part of that change is new knowledge. And we have to be willing to try new things so that we can continue advancing. So this type of technology at this point is emerging, but it's going to keep maturing because it's an exponential development also of holographic technology. So we'll reach the point where we will have what we see currently in the movies. But is that the end of it? No. So we have to continue development. We have to continue asking ourselves questions. What's next? What's next? What's next? Where can we make a difference? Where can we make a positive impact? And try things. And that's another advice that I give to everybody, is that not taking risks doesn't help with development. And if you look throughout history, we have taken risks in every aspect of our human endeavor to advance. And yes, sometimes we fail, but many times we win. So unless we try new things, we don't know what's the potential. We don't know how far right now your technology that you're involved with is going to make a difference in medicine, is going to make a difference in not only the quality of life of people, but also the actual lives of people. You never know. But unless we keep pushing the envelope, then we're not going to know for sure. So definitely, constant change, we should welcome it. We should not be afraid of it. Yes, people right now going in space, commercial spaceflight participants. At this point, in the United States, it requires informed consent, which means that all of these individuals that you see going in space right now in commercial space vehicles, they have to accept the risk of going in space, which is risky. Yes, it is. But as long as you are well informed about what all the risks and you are willing to accept the risks, why not? And that's why that's happening right now. So we need to keep pushing that. We need to keep pushing, of course, the importance of science, math, the importance of development of new knowledge, because that's also the way we grow. Let's think about everything that we are doing. In fact, your holographic technology right now would not be possible without the development of microchips. And what has been the exponential development of the microchips? Very fast. But now we're also reaching a limit on how many more transistors you can squeeze into the matrix that we currently use, which is silicon, so that we can continue developing the next generation of microchips. Well, there are developments, but we're looking at new materials. So how else do we go in that direction? Could we end up at some point in the future having a biological microchip where we actually create a microchip equivalent by manipulating DNA? That's a possibility, molecular chips. Why not? But once again, we have to be open to possibilities and be excited about those possibilities.
Wow. Melchor, thank you so much. It has been one of the best interviews that I have in my channel. Thank you so much for this opportunity. And everyone, thank you so much for watching. Don't forget to subscribe and see you next week. Thank you.
Thank you, Fernando.